fact, not to mention the audio degradation that can take place going through sound cards multiple times. So a lot of advantages there. So here is the AOIP sort of domain, if you will, a very simple concept drawing here. You're still obviously going to have plenty of legacy sources, that is analog, AES3, mic and line level signals. So there's at one end of the chain, there is a box where you plug in, mostly often called a node, that allows you to plug in as many multiple inputs or outputs of legacy devices to it, and one RJ45 comes out from all that. Kind of just like a snake, except that it's just an RJ45, so it is an active device that's essentially packetizing and labeling and addressing all these different sources and destinations at either end. And then once it's in that IP domain, from that point forward, it's on a bidirectional path that goes to an Ethernet switch. That's usually a small switch in, say, a small room. They call these the edge switches. And that small switch can talk to a larger switch, which is the core switch for the entire facility. So if you think of this as a multi-room facility, you've got a number of edge switches spread around, talking to one big core switch. When the system needs to, or the facility needs to expand, it's usually the core switch that gets upgraded. In fact, if you're really into a big system, you could actually put an IP router. They call IP level devices routers, Ethernet level devices switches, even though they basically do the same thing. Just direct packets from one place into from a source to a destination. You don't necessarily need all the power of IP, because the IP is designed to handle the entire internet, the entire world. Ethernet is usually designed more for just being able to handle the LAN base. In most cases, that's enough. But in any event, a small one at the local and the studio end, generally you never outgrow the edge switches, and if you ever need to do anything, you might just upgrade the core switch. And then if your sources are not legacy sources, but in fact computer-based, they can just connect directly without going through one of these nodes, because they don't need to be packetized. They're already packetized. In fact, you can get rid of the sound card you used to need to get from that into the old legacy audio environment. So you get rid of this sound card and just install a driver that allows the PC to talk directly into the IP-based system. At the other end, obviously, this is written for radio, where you have studio to transmitter links. They can extend the IP network, the local network, through a dedicated IP path to the actually all the way out to the transmitter, or to another studio. This could be a studio-to-studio link. And it can go out to internet streaming locations, which are often done by third parties for broadcasters, directly to the internet that way for the public. And that is the internet then, but you're sending IP-based stuff to them through dedicated paths. And then obviously around the facility. It can go back through one of those nodes out to an XLR connector for AES or analog audio. Meanwhile, there's not just audio passing on this, there's control. You can have GPIO switches, relays, anything connected to it, because again, the IP-based system does not just allows more than just audio to pass through it. And in fact, you can envision having graphics, even video, being also accompanying and just bonded to whatever signal you want to create with these IP systems. So very upgradable in terms of content types, both audio, data, and other TBD. So to get into a little bit of IP, if you're not already familiar with it, we're talking about packet switching, talking about the layering of a network. There is prioritization and management of that network that kind of takes place a little behind the scenes. And then there are the issues of IP multicast or Ethernet multicast as well, which you don't hear much about. We heard a lot about it a few years back when it was going to be the solution to internet streaming. It never really happened because it wasn't fully deployed throughout. It would have to be deployed end to end throughout the internet for that to work. However, you can very easily deploy it in the LAN for the studio, and in fact, most of these systems use exclusively multicast, not unicast, so that it allows a single source to be available to every destination if you wanted it to be. In fact, for things that you want to literally go to every place, you do what's called Ethernet or IP broadcast. But typically, multicast is available to as many sources as you want. And you can limit that if you don't want certain sources to go certain places. But the default is any source, any single source can go to any multiples of destinations. And this is great for things like, even things like the house tone, sync, whatever. You just put it up there and everybody can get it. But it's also great for, particularly in a broadcast facility, when you have an incoming signal, you may want, several studios may all want pieces of that, or live or later. And so having that source be available, and literally the way these consoles are built, every input strip is a source and a destination. So you can use things like mix minus for calls, as well as taking a single source from a single mic input, or taking the whole mix from that one console and routing it to wherever you want to go. So very flexible for that. Same goes in a post facility as well.